With the increased amount of surface treatment being done in the state of Pennsylvania, the following presentation may give you some helpful hints in obtaining a higher quality and more durable product. Virtually all asphalts used in the United States are products of the distillation of petroleum crude. Asphalts are produced in a variety of types and grades, ranging from hard and brittle solids to almost water-thin liquids. Asphalt cement is the basis of all these products. It can be made fluid for construction uses by heating, adding a solvent, or by emulsifying. When a petroleum solvent, such as naphtha or kerosene, is added to the base asphalt to make it fluid, the product is called a cutback. When asphalt is broken into minute particles and dispersed in water with an emulsifier, it becomes an asphalt emulsion. The use of asphalt emulsions for road construction and maintenance is not new. Emulsions were first developed in the early 1900s. It was not until the 1920s that emulsions as we know them today came into being. There are several factors that contribute to the increased interest for using emulsions. The energy crisis of the early 1970s, reduced atmospheric pollution, the ability of coating damp aggregate, and cost savings. Asphalt emulsions consist of three basic ingredients: asphalt, water, and an emulsifying agent. It is well known that water and asphalt will not mix, except under carefully controlled conditions using highly specialized equipment and chemical additives. The blending of asphalt cement and water is somewhat like an auto mechanic trying to wash grease off his hands with plain water. It is not until the detergent or soap of some type is used that grease can be removed. The soap particles surround the globules of grease, break the surface tension that holds them, and allows them to be washed away. Some of the same physical and chemical principles apply in the formulation, production, and use of asphalt emulsions. Asphalt emulsions are divided into two categories: anionic and cationic. In practice, these two types are ordinarily used in roadway construction and maintenance. The anionic and cationic classes refer to the electrical charges surrounding the asphalt particles. Cationic is a positive or plus charge, and anionic is a negative or minus charge. Like emulsions, aggregates also contain these types of electrical charges, positive or negative. Since like charges repel one another and unlike charges attract, it is imperative that we match the right aggregate with the right emulsion. This means that positively charged aggregate must have a negatively charged anionic emulsion and vice versa. For example, cationic oils, which are E1C, E3, E5, and E8C, would be matched up with silica, quartz, and gravel. And anionic oils, which are E1A, E2, E4, E6, and E8A, would be used with limestone. Advanced planning is the key to any successful operation. In this case, the maintenance manager reviews the roadway system in his county and determines what roads would benefit from a surface treatment or seal coat. An assistant county maintenance manager is selected to coordinate all surface treatment work. The county manager and his assistant plan the sequence in which the project will be done. This will help ensure better coordination of work with the other assistants so that all the preliminary work, such as drainage, patching, tree trimming, shoulder cutting, and other work, is taken care of well in advance of the surface treatment. After the aggregate source has been selected, an oil and aggregate compatibility should be established. This can be accomplished by sending a sample of the aggregate, approximately 7 pounds, to the emulsion supplier, and he will determine what oil should be used with your stone. You must determine the asphalt and aggregate application rate. Use Pennsylvania design method for seal coats and surface treatments. Design procedure can be found in Bulletin 27. Adapt this procedure to fit the job conditions. It is intended to be flexible. The aggregates that you are going to use should be free from dirt. To check this, one or more wash tests should be performed at the plant prior to shipment. The county manager also reviews his work program with his equipment manager to ensure that men and equipment will be available when needed. The equipment manager keeps track of the crew's progress and dispatches equipment as needed. A highway foreman is then selected to run the program in the field. He is briefed on the entire program, including the availability of men, equipment, and materials. The assistant in charge and the foreman will review the routes that are planned and make sure that all preparatory work has been completed. A very important piece of equipment on this operation is the oil distributor. To expedite production, 2 distributors will be used. Make sure your distributors are in good working order, calibrated, and have the correct nozzles. Your aggregate spreader is perhaps second only to the oil distributor in order of importance for a good surface treatment. Again, make sure it has been calibrated and is in good working condition. Rollers are needed to properly embed the cover aggregate in the freshly placed asphalt, which will prevent the loss of aggregate from traffic abrasion. For oil and chip surface treatments, 2 pneumatic tired rollers produce the best results in order that sufficient coverage is made in one pass. Unless the surface to be covered is completely clean, the asphalt emulsion will not adhere to the surface. Thus, a power broom is required to clean the surface prior to treatment and to remove loose stone after the treatment has been cured completely. Enough trucks must be made available to ensure that the operation can proceed without interruption. Frequent starts and stops will cause a non-uniform application of stone. The use of a pilot car for traffic control is advisable. Keeping traffic off the surface treatment until it has cured is imperative. After selecting the oil, stone, and proper equipment, you must also select personnel that are properly trained for surface treatment operations. Because backing up trucks is a key part of this operation, equipment operators and maintenance personnel must be alert. Inexperienced personnel may get someone hurt or killed. It would not be unrealistic to have a few dry runs backing into and hooking up to the chipper prior to the actual operation. It is not our intent to embarrass anyone by showing defects and errors in these slides. It is our intent to invite your thinking about the procedures that must be done to ensure success. Look at your jobs at intervals after they are done, and if there are flaws, try to determine what caused them, and let your next job profit from your experience. Not all of our oil and chip surface treatments have turned out well. If the cause of failure cannot be identified, more failure can be expected. Your chance of success is best when the temperature of the road is 80 degrees or more, and the likelihood of failure increases as the temperature drops. At less than 60 degrees, you're almost certain to fail. The best months for surface treatment are June, July, and August. Prior to the beginning of the operation, the road surface must be thoroughly cleaned. If prior inspection indicates that the surface is very dirty, consider sending the sweeper out a week in advance, preferably in the rain, and again very early on the morning of the job. The foreman sees that the oil is delivered on time to the planned transfer site. He ensures that the oil is delivered at a temperature within the range of department specifications and is the right type. It is important that you use a spraying temperature that is within the manufacturer's range for that particular product. For example, department specifications may say that spraying temperature must fall within the range of 145 degrees to 170 degrees. The manufacturer may design his oil so that its proper spraying temperature is between 150 degrees and 165 degrees. In this case, a temperature of 170 degrees would be much too high for this oil, in spite of the fact that it is within department specifications. The foreman checks the spraying temperature range recorded on the delivery slip and advises the oil distributor operator that the oil is within the manufacturer's temperature range before the asphalt is sprayed. The foreman should verify the accuracy of the external thermometer against the thermometer located under the cab, in this case just to the left of the dial thermometer. On the job site, the foreman ensures that everything is right before starting. He and the oil distributor operator review the pump pressure, the temperature of the oil in the distributor, and the spray bar height. When everything is suitable and he has enough aggregate on hand to cover the distributor's load, the foreman tells the distributor operator to go. The distributor operator attains the calculated speed before he turns on the spray bar, and he runs at that speed until there is only about 50 gallons left. He shuts off his spray bar before the tank is completely empty because the last few gallons will not spray uniformly. As the distributor begins, the foreman makes one last check. It takes a good eye to see defects in a triple spray pattern. Here a couple of defects were deliberately put in just so you could see them. The first nozzle was turned 90 degrees so you can see the fat streak it causes on the center line. It is not easy to see, but about 4 inches to the right of that, between the second and third nozzles from the left, is the lean streak. Streaking usually occurs when there is not uniform coverage of oil on the road. It is not generally recognized that the height of the spray bar is a major cause of streaking. This is because, with a triple lap spray, uneven spray is hard to see on the road. The whole width of the road seems to be covered. But if you are supposed to be spraying 3/10 gallon per square yard, 1/10 plus or minus will cause bleeding or stripping. You will also get streaking if all the nozzles are not a matched set, including special end nozzles. This slide shows 2 different types of nozzles. The nozzles on the left side are a flat style type, while the 3 on the right are a round head type. What is also not usually recognized is the interrelationship between spray bar height and nozzle angle. The top of this slide depicts the spray bar as it would appear from behind. The bottom of the slide shows the spray pattern on the road. Obviously, all nozzles must be set at the same angle, 15 or 30 degrees. But the spray bar height must be adjusted for a triple lap so that the spray from every third nozzle just meets. If the spray bar is too low, you will have a lean double lap streak of only 0.2 gallons. If the spray bar is too high, there will be fat streaks of 0.4 gallons per square yard, which will cover the stone and give you bleeding streaks. Here it is pretty clear that the emulsion is not evenly distributed across the road. Although the road is covered, the fat and lean streaks are apparent. The spray bar was too low because this was the beginning of a shot, and the distributor was full. As the distributor empties, it gets lighter, and the springs lift the body and the spray bar. You will have to determine your spray bar height with a half load in the distributor to split the difference and minimize the problem. There are some distributors that have a self-leveling mechanism that keeps the spray bar height constant. One way to illustrate this is to plug all the nozzles except every third one. Set the nozzles to the same angle and raise or lower the spray bar until your test shot proves that these give you a perfect single coverage. Then replace the other nozzles and adjust them to the same angle for a perfect triple lap. You should do this at the beginning of every season to ensure that your spray bar height is just right for the angle of your nozzles. If one of the nozzles is at a different angle, it'll leave gaps. Here the center nozzle is set at 30 degrees, while the others were set at 15 degrees. Here is a transverse joint. It looks as if the oil distributor had stopped and then tried to begin spraying from a standing start. It is obvious that the oil distributor was not moving at the proper speed when he cut in his spray bar. In the few feet that it takes to get up to the correct speed, the oil was coming too fast, Normally, that would cause a fat spot at the joint. Here is a joint that was one of the few places that the aggregate stuck. Because the original surface was hungry, it absorbed so much oil that there wasn't enough to hold the aggregate, except where extra oil was applied accidentally. No matter what type of distributor you have, it cannot give you a neat joint from a standing start. The standard procedure to minimize irregularities in transverse joints is to back the spray bar as far as possible over the joint, cover the fresh mat with paper, and hit the joint as the spray bar passes over it. Once your distributor starts, ideally the operator should not stop until his load is dispensed. The trick is to have all the aggregate you're going to need on hand, loaded and ready to cover that much oil before you let the distributor start. Here the chip spreader has gotten too far behind. The oil distributor operator must keep an eye on the chip spreader and stop if it gets too far ahead of the spreader. In most cases, you should have 15 seconds to apply your aggregate before the oil starts to set. The total time from oil application to actual rolling should not exceed 30 seconds. Have the oil distributor run at a slower speed and the chip spreader run at a speed fast enough that the distributor will not have to wait. It is much better to stop and start the spreader. The rolling should begin within 10 to 15 seconds after the chips are spread. Within a few minutes, the oil is too cool and resists the movement of the chips as the roller tries to rearrange them to their least dimension. All rolling must take place before the oil takes a definite set or hardness, because continued rolling will break the bond between the stones and the oil. The rubber-tired roller is the preferred roller for oil and chip work. Two of them will do the job just fine. If you must use a steel wheel roller, don't overdo it. One more thing. If you must use a steel-wheeled roller, use the rubber-tired roller first. The rubber-tired roller gives more uniform pressure. After the first half of your job is cured, sweep the other side again to remove all the loose aggregate before you oil it. Traffic control is needed to keep vehicles from ruining your surface treatment. Usually you'll have to keep the route open, but temporary delays to traffic are acceptable and necessary. If you have to keep the highway open for traffic, do only one side in a day. If you switch to the other side as soon as you get to the end of a project, you are forcing traffic to travel on your new treatment before it is cured. Give your job at least 4 hours to cure. Control the traffic. Never allow traffic on oil before it's covered. Any vehicle that must use the new surface before it's rolled, including your aggregate trucks, must be held under 7 miles per hour. Any vehicle that uses the new surface within 4 hours after it has been rolled must be held below 25 miles per hour. To prevent excessive speed on the new surface, use a pilot car to control traffic. Also, temporary speed limits may be erected to help slow traffic. Remember, make sure the surface prep is done. The surface is clean, the stone and oil are compatible, the equipment is in good condition and calibrated, the temperatures are right, and the traffic control is in place. Employees feel that if the boss doesn't care, or if he doesn't show he cares, which gives the same impression, why should they? The key to any operation is supervision. The supervisor must know what causes failure and prevent it. He must know what makes a good job and see that he is getting it. He will not operate the equipment, but he will know whether they are functioning properly, and if not, why not? By using good practices and proper procedures, you will be taking giant steps forward to producing a durable and cost-effective product.